In section 8.4, our objective is to be able to verify characteristics of quadrilaterals and use properties of quadrilaterals to solve real-world problems. Now, specifically, we want to verify characteristics of certain types of quadrilaterals. They will be the rhombuses, the rectangles, and the squares. Let's recall, first of all, what is a quadrilateral? Quadrilateral is a four-sided polygon. Polygon with four sides. A parallelogram is a type of quadrilateral. It is a quadrilateral that has the following 6 characteristics. Where does the word parallelogram come from? First of all, parallel sides. The opposite sides are parallel. Those sides are parallel. Those sides are parallel. So we describe this property, this definition, by saying both pairs of opposite sides are parallel. Both pairs of opposite sides are parallel. What is another characteristic? Opposite sides are congruent. Not just opposite sides, but we say both pairs of opposite sides are congruent. What's another characteristic? Put the two together. A pair of congruent sides, and they are also parallel. So the same pair, or one pair of opposite sides, are congruent and parallel. So we combine those first two properties. Then we move to the angles. The opposite angles are congruent. So we say both pairs of opposite angles are congruent. What else about the angles? The consecutive angles, the angles next to each other, well, what has to be true about them? If this is 100 degrees, then this will be 80 degrees. They add up to 180 degrees. So we say the consecutive angles are supplementary. And not just one pair, but all of the angles that are consecutive. So also these two right next to each other. Those will also add up to 180 degrees. Any consecutive angles in the parallelogram, supplementary. And finally, about the diagonals. Well, let's draw the diagonals and get a visual to help us remember. This is what we see. The diagonals bisect each other. Diagonals bisect each other. So that's a review of a quadrilateral and the 6 properties of parallelograms. Today we get more specific into types of parallelograms. If we narrow down a parallelogram in certain ways, we get more specific types of parallelograms like the rhombus and the rectangle. Both of them are types of parallelograms. So we will say a rhombus is a parallelogram that has the following 3 things. 1, all 4 sides are congruent. So remember back to the parallelogram picture, just the opposite sides were congruent. Well, if all 4 sides are congruent, still the opposite sides are congruent, but now it's a little bit more specific. All 4 sides are congruent, then it is more specifically a rhombus. If I draw the diagonals of a rhombus, you'll notice in this picture after we draw them that they make a T shape or a right angle. The diagonals are perpendicular in a rhombus. Diagonals are perpendicular. So you can think to yourself that means they make a 90-degree angle. Also, pertaining to the diagonals, if I draw them, notice that the way they intersect at the angles, the way they connect to the angles, is that they are bisecting the angles. This angle and this angle are congruent to each other. This angle and this angle congruent to each other. The angles are being bisected by the diagonals. Each diagonal bisect the opposite angles. Now we can go the other way. If we have a parallelogram that's more specifically a rectangle, it's because of the following. Now let's start by saying a rectangle is a parallelogram. So it contains all of the characteristics that we listed above, all of those 6 characteristics in the parallelogram section. So it's a parallelogram, but it has more specifically 4 right angles. You know what? I'm not just going to say 4 right angles. I'm going to say all 4 right angles. Okay, so all of the angles are 90 degrees. They are all congruent. So all 4 sides are congruent makes a rhombus. All 4 angles congruent makes a rectangle. One or the other. Either it's a rhombus or it's a rectangle. The other property has to do with its diagonals. If we draw the diagonals in this picture of a rectangle, I'm going to draw this one a little bit better. Hopefully you notice that the diagonals are the same size. How do we show that? Well, this piece and this piece, of course, are congruent because the diagonals bisect each other in the parallelogram. But unlike how we changed this to 2 slashes and 2 slashes, because these diagonals are the same measure, it's going to be the same types of slashes. So the diagonals are congruent. Those 2 properties make a rectangle. So you can have a parallelogram that's either a rhombus or it's a rectangle. Then you can have a parallelogram that is both. So a square is a parallelogram that is both a rhombus and rectangle. It's both of those things. So if we say, well, a rhombus has 4 congruent sides, so does a square. If we say a rectangle has 4 congruent 90-degree angles, well, so does a square. It has everything that both of those have. So you may want to make yourself a note that if something is a square, it has all of the characteristics that were listed from above. Because it's everything. Rhombus, rectangle, parallelogram. It's the most specific name if it has all of those characteristics.